Hi everyone. In this video we're going to learn about separation by precipitation. And if you remember in that previous problem that we did, we had a solution containing copper 1, lead 2, and tin 2 ions, and we added iodide and we figured out that copper 1 precipitated first and then lead 2 precipitated next. So the question that we asked is, can we precipitate all of the copper 1 before lead 2 starts to precipitate? So believe it or not, we actually have to define what we mean by all. So the criterion of all kind of has to be defined. A separation is considered complete if 99.0 to 99.9% of one ion precipitates before the other starts to precipitate. So let's see if we can do an example here. Imagine that we have a solution containing 0.1 formyl potassium iodate and we add calcium ions. We're given what happens is that calcium will precipitate with the iodate, and we're given the solubility product of that calcium iodate precipitate. They want to know, what is the calcium concentration when 99.0% of the iodate has precipitated out? So if 99% of the iodate, and that's this iodate here, if 99% of it has precipitated out, doesn't that mean that 1% of the iodate is left in solution? And can't we calculate that? 1% of that initial iodate concentration, 0.10 molar, wouldn't that be 1.0 times 10 to the negative third molar iodate left in solution? And if that's the case, we should be able to easily figure out the calcium concentration simply by using this KSP. So as always, I'm going to write my reaction. Calcium iodate dissociates into calcium and 2 iodates. And at equilibrium, when 99% of the iodate has precipitated out and there's only 1% left in solution, we've got a lot of solid that formed. What is the calcium? Now 1% left, we figured out that concentration for iodate, that's 1.0 times 10 to the negative third molar. So KSP is going to be calcium times iodate squared, and calcium will be the KSP, which is 7.1 times 10 to the negative 7th over iodate, 1% left, is 1.0 times 10 to the negative third molar, and don't forget to square it. The calcium ion concentration will be 0.71 molar when 99.0 of that iodate has precipitated out, and you'll still have this much iodate left in solution. So hope you enjoyed that video, and thanks for listening.